Welcome students to another video lecture with Mr. Kinnett here. We're going over lessons 5.9 and 5.10 in our textbook, and we're learning about similar figures and indirect measurement. So we're going to learn how to kind of recycle this skill of cross products on ratios or proportions to solve problems, and it can be used on shapes as well. So I'm going to pause here and let you copy down what you see first. Welcome back, students. So our essential focus here is how do we determine if shapes are similar? And we're going to learn that in the beginning parts. We're going to have a little bit about geometry and then what their scale factor is. So when I'm talking about this scale factor, I'm really thinking about that constant ratio that if they are similar, they're both going to have. So I used a different word, scale factor, in this lesson that we cycled from 5.8 on similar or on scale drawings. But really, just so you realize, scale factor is really similar to constant ratio. Okay, so we're learning about similar figures and indirect measurement. So what we're learning about similar figures is that if they have the same shape, but not necessarily the same size, there are a couple true things about them. The key here, though, is if they're not the same shape, nothing we're doing works. So first off, they have to look like the same shape, and we're going to learn about symbols that help us know whether they really are the same shape, and it just doesn't have like a artistic illusion that they are the same. So first off, if they are the same, one thing they're going to have the same is the angles are congruent. Congruent is just really a fancy word for same size. So shapes that are similar will always have angles that are exactly the same. So that's important. The second thing that we're going to learn about these things is corresponding sides on similar figures are proportional. Really, when we used proportional in this sense, what it means is all the sides have the same ratio if we were comparing one figure to the other. Okay, and that's where that scale factor in our focus question, our central question, is going to come from. We're looking for that constant ratio when we compare one side to the other. So right now we got to learn a little bit about some geometry here. So I have it done on our congruent symbols here on our triangle. And I'm actually going to erase this and just have you copy what you see in front of you right now. And then we'll start adding that part right there. So it gives you an idea. We're going to have a little bit of space here, but the words you want to know as we go through this part are, this is the symbol for triangle. This is the symbol for similar. This is the symbol for congruent, and this is the symbol we're going to use for angle. And that's because mathematicians, remember, are extremely efficient, and they like to make up symbols to make their writing shorter. So go ahead and pause here and copy down what you see. Okay, so we have two triangles, and I think you can see they kind of look like they are the same size. In fact, or not same size, same shape. I've actually copied them from the computer, so I do know they are exactly the same shape. I just scaled one down and scaled one up a little larger. So the first thing I'm going to teach you is how you name a triangle. So when you name a triangle, we always start with its symbol, triangle, so that we know we're about to name it. And then we choose an angle to start naming it by. And many of you are going to always want to choose the ABC, the alphabetical order. But I'm going to model that you don't have to go in alphabetical order and that there is a way to figure out the system for the second triangle. So I'm going to name my first triangle, that larger triangle, BAC. So really, I went around the triangle counterclockwise. You either have a choice to go clockwise or counterclockwise. Now, triangle ABC is not congruent, remember, a fancy word for the same, but it does look similar to the other triangle. So we're going to use the similar notation, and then we're going to look at that next triangle there. And when we name the next triangle, we have to use the exact angle that aligned with B first. So which angle is congruent to B? So which one of the other shapes, angles, has the same exact size as B? And I started using this notation here, these curved parts right here and here and here. These mean those angles are congruent. That's how you show congruence on angles. So angle B is exactly the same as the other three-lined angle on the other shape, which is angle Y. So we have to start calling the next triangle angle Y. And then the angle that went with angle A over here is angle X over here. So we have to go that order. And angle C is the same as angle Z. So we used their congruent angles when naming the triangles. So if you went counterclockwise BAC, you should also hit the same exact angles YXZ as you go counterclockwise. Okay, so the first thing we learned how to do is write similar triangles. The next thing we're about to learn is that we can relate the angles to each other. So angle A is exactly the same angle, so it is congruent to angle X. And that angle symbol is kind of like an acute angle. It's a sideways acute angle. We are supposed to keep it flat if you see my board messing it up at all. Angle B is congruent to what angle on the other shape? Yeah, it's angle Y. Awesome. Now, we have our last angle, angle C of our triangle. Which shape or angle is congruent to angle C on the other shape? Yeah, it's angle Z. Okay, so these are things that are happening because we have similar figures. These are the same shape. So we just showed angles are congruent. And now it's the second part, the similar figures will have proportional sides. So we're able to create the same ratio. That's the really important part of this lesson because this is where our math comes from. What we will see here is that the ratio of side AB, so we name AB, and that's going from angle A to angle B, has the same ratio as if you went from angle X to angle Y, those congruent angles. So if we divided AB by XY, that's going to be exactly the same as if we divided side AC on the big shape here, so went from this angle to this one, divided by X to Y. Or sorry, X to Z. Gotta realize what I'm pointing at. And that's the same exact ratio as if we went BC divided by, so if we looked at B to C, we're looking for those letters that are congruent to it, which would be Y and Z. And we could keep on going, naming these sides CB, just going backwards. But what's really important here is that we have to realize that when you have similar figures, the sides have the same ratios. So these are the ratios. So whenever we're given two sides or one side on a figure, and then they give us a number on another side, and they tell us one other number, we can actually use this ratio to solve for the missing side. And we're going to have an example 2 here. Go ahead and pause down and copy down what you see. All right, welcome back. So we're going to continue that part where we're creating these proportional relationships. We're going to try and look for that ratio. So I try to model this like Alex, and this is really common. Notice they've given us 5 numbers and 1 is unknown. When we solve proportions, we're used to seeing them as some sort of ratio equal to another ratio. So we want to keep in mind, this is what we're trying to build. They're commonly going to give you too many numbers, and you don't have to use all of them. You just have to make sure you're using the right ratio and connection from one side to the other. So let's just use this 12 centimeters as our first number. Now, just like when we did our similar figures and our proportional problems, we have to be fair. I'm putting large triangle information on the top and small triangle information on the bottom. That means when I set up the ratio on the right side of this equal sign, I have to follow the same pattern. So 12 centimeters. Well, turns out 12 centimeters aligns with this red angle to this black angle. So we're looking for red angle to black angle on the other figure. How long is it? Yeah, you're right. It's 8 centimeters on the other shape. And that's the same exact ratio as if we took, well, we're trying to find this y on the small figure. So I'm going to put that on the bottom here. And I put it on the bottom because the y is part of the small triangle. And we're putting our large triangle information on the top. So which side aligns with y from this small figure? Which side is the same as green to red angle? Yeah, it's 6 centimeters, so we put that on the top. And now we're going to use our cross products to solve the problem. 6 times 8 is 48 equals 12y. We're going to divide by that 12 to get the 12 to leave the y alone. And y equals 4. So the missing side on that triangle is 4 centimeters long. That's what we're able to use because these are similar figures. I'm going to show you a different shape just to show you that it works on any type of similar figure. We're going to do this on some parallelograms. Go ahead and copy down what you see. We're going to solve this example in class. And I mixed up my examples, if you noticed. I called my first example example 2 and my second example 1. And we'll leave it confusing. That's fine. Go ahead and copy down the parallelograms on the board there. Great job. Now leave about a thumb space of distance because we're going to write down a little bit of information on indirect measurement now. We're going to solve that parallelogram problem in class. So again, leave space before you start copying down what I show you. And I'm going to go 2 slides ahead so you can copy down all that we need there. Actually, that's a bad idea. You're going to write right below there. So just copy down the indirect measurement right now, and we're going to show you a picture of what we mean. Okay, welcome back. So again, don't copy down this example just yet that I'm showing you. I'm going to try and teach you how to draw the pictures first. So when you are using indirect measurement, it's a really cool skill of measuring things that are way too tall to measure with a measuring tape. And what we're going to use here is we're going to use shadows and the angle of the sun to figure out a height. And many students don't understand how to draw this picture. So what I want you to imagine, almost all these pictures are going to draw the same exact shape. So as I draw this figure, I want you to think to yourself, what shape is being created? So first off, we're going to have a human here. You know I'm a practicing artist. So there's my human. Okay. And we know this human is, we're gonna use meters just because it does make things easier. We're gonna say this human is 2.5 meters tall. Well, you have to think, anytime you're standing outside and there's not cloud cover, what is definitely hitting you on your body? It's the beautiful sunshine coming from the sky there. Okay, and whenever you're outside, on most times, other than maybe high noon, you will have a shadow. So all of these problems use the fact that the sun angle at any given moment in time is exactly the same for any shape close to each other on Earth. So what I mean by that is my shadow is going to have the same ratio as the school's shadow on the ground. Since we're really close on Earth, the sun has the same exact angle. So then we have this shadow that forms on the ground there. And they'll usually tell you your shadow length is something like 4 meters long. And it's usually longer than you are because it's extending itself on the ground. What shape did we create in this drawing? Do you see a shape at all? Yeah, you're right. It's a triangle. So all of these indirect measurement problems are being done on triangles. So I'm going to have you copy down this last example in our 5, 9, 5, 10 note, and we're going to solve that in class. And then I'd love to try and possibly get outside if the weather is coordinating or working with us to do some measurements of some tall trees. It may be fun. So thank you all. Remember, write your questions in the question columns if you have any. copy down all the questions that you see here. And those questions are great to bring up in class because they remind me that you need help. Thank you so much, students. I'll see you soon.